Okay, so today we're going to do a density lab review. You can see in step 2, density graphs. We are going to open up this document right here. When we open up the document, just kind of go through the document real quick. We have a title, density lab. There's some instructions with safety note, use care when working with any material, especially when you don't know what it is. Pre-lab questions, so we're going to have to answer those pre-lab questions as we kind of scroll down the page. There's a procedure here. Now this procedure is going to be very different. So that's why I'm going to walk you through the demonstration, because we're not actually doing this in class. This is part of the changes that we have to make right now. So I will go through those procedures. You can almost ignore that part. But I do want to show you down here at the bottom, you have a tab that says instructions and a tab that says data tables. You need both. Okay, you need to look at both. The second data tables tab is actually where you're going to be inputting your data. Okay, so let's go through the lab that we're going to do today. Data table 1, we need the mass of the empty tear cup. So we're going to have a liquid. Liquid A has already been done for you. You have the mass of just liquid A for the first measurements, the volume they end up with each measurement, and then we're going to do liquid B together. Okay, so let's go ahead and find the mass of the empty tear cup. That's what we're going to put in this box right here. So let's go to our camera, and you can see that I have a scale right here. I have some beakers, and I have one that has some liquid in it. So we'll be pouring from this one. Okay, we're going to use this empty glass for our tear cup. I'm going to move my scale into view a little bit better. I'm going to turn it on. Place the empty beaker right on the scale. And let's see if we can't see that mass. Okay. So the empty cup is 53 grams. The empty beaker is 53 grams. Let's go ahead and put that into our data. Our empty beaker is 53 grams. Okay. So now we're going to add 10 milliliters of our unknown liquid, and we're going to find out what that mass is. So we're going to go ahead and just go back to our camera, and you can see what we're doing. We are going to add just to that first line, 10 milliliters. That raises our mass to 58. So if we come back to our data, are we going to put 58 grams right there? No. We need to say, okay, it's 58 minus 53. That gives me 5 grams. So in this box, I'm going to type 5. And I just need the number because grams is in the top of my data table. Right? And I have 10 milliliters right there. I don't need milliliters because I've got that in the top of my data table right here. All right, so I'm going to come down again. I'm going to add another 10 milliliters of my unknown liquid. Let's look at our camera. We're going to go 10 milliliters. All right, and that raised it to 69 grams. So 69 grams. I'm going to come back to my data. I have 20 milliliters, and I have 69 minus 53. Now, I can do this in a formula. I can come up here to the formula bar, and I can say equals 69 minus 53, because 53 was the mass of my tear cup. And I can go equals, and that gives me my number. Okay, so then I'm just going to keep adding increments of 10 milliliters. And let's go back to our camera and see what that does. It gives me 30 milliliters, and we have 76 on our scale. So we're going to type in 30 for our milliliters. And right here, we're going to do that formula trick again. Equals 76 minus 53, which was the mass of your cup. So I'm going to hit enter. That gives me my data. I'm going to do this again. Okay. And this time we come up a little bit short. So we're going to call that 39 milliliters. And we come to 84 grams. So we really didn't have quite enough 39 milliliters. And this time we had 84 grams. That's the glass, the beaker, and the liquid. So we're going to go 84 minus 53, because 53 was the mass of our empty cup. And hit enter, and we'll just leave this one blank. No big deal. Okay, so why would we do this? What's the point? When we look at our data tables, we're looking at our numbers. You should be turning this in, okay? I'm going to come down here, and we see we have a line graph that is produced from our data. Now let's digest this graph really quick. Make this a little bigger so you can see. All right, if we look here on the y-axis, we have mass. Mass is going up the y-axis. That's going to come into play here in a second. And across the x-axis, we have volume. So what is density again? Density equals mass divided by volume. So y divided by x, does that sound like anything you've learned in math? That is the slope of this line. So the slope of this line, notice how this is a perfectly straight line and all the dots actually meet right on the line. Well, except that outlier. Probably a little calculation error there. But all of them meet right on the line for the most part. So the density of the liquid is the slope of the line. Rise over run is slope. So the rise of this graph is mass over the run, which is volume. And so that'll be asked of you just a little bit later. But back to this data table, we should have this filled in, and that was for liquid A. Let's look at liquid B. If you scroll down just a little bit, you can see liquid B also has a pretty straight line. So the slope of this line is the density of the liquid. So mass over volume is the density of the liquid that you're looking at. So the next step for you is to answer these questions right here. What is the density of liquid A? Well, there's a couple of ways that you could do that. If you want to go look at the slope of that line, that's one way you could do that. Or you could click in here to the box, okay? And you could look at letter A, find a mass and a volume, and type it in here, because density equals mass divided by volume. So for liquid A, that would be 10.3 grams divided by 10 milliliters, and that's going to give me a density. So when I plug it into my calculator, 10.3 divided by 10 is 1.03 grams per milliliter. Okay, that's a good answer for that question. Okay, then we're going to click down liquid B. You can do that. Which liquid is water? Well, if you know that the density of water is 1, then you can match it up. Which one? Liquid A is really close to 1, but you have to look at B and see which one matches the best. I just told you that one. Number 4, how do you know which liquid is water? You have to match the density. And this one we talked about the graph earlier. So the relationship slope of line, the slope is a rise over run. So if I come and I look at this data table, if I come and look at this graph from the data table, rise is mass, run is volume. So density is the slope of this line that is created right there. All right, I hope this helps. I hope it makes sense. Have a great day.